Today we're going to work on balancing this reaction. Here we have a hydrocarbon, that's this one right here. We have oxygen gas, and it's forming carbon dioxide and water. This is a very simple combustion where we have a hydrocarbon and then the combustion products of CO2 and H2O. We will see quite a few combustion reactions where we have different hydrocarbons that have different numbers of carbons and hydrogens, but let's get started on this one with C3H6. I've written here our reaction now. We have C3H6 plus O2, which is oxygen gas, plus CO2, which is carbon dioxide, plus H2O, which is water. Our first step will be taking all of the different elements, and I like to write them down underneath the products and the reactants. So we have our reactants right here, and then we have our products over here. Let's do our initial counts. Over here, we have 3 carbons, we have 6 hydrogens, and we have 2 oxygens. The way that we get these counts is right now there's no coefficients in front. So all we have to do is look at our subscripts. We don't have any parentheses, so this 3 goes to the carbon, there's 3 carbons. This 6 goes to the hydrogen, there's 6 hydrogens, and this 2 goes to the oxygen. We can come over here and do the same thing, but now there is a little bit of a tricky situation. We have oxygen in 2 things. We have oxygen right here and oxygen right here. Our count for carbon is 1, our count for hydrogen is 2, and then our count for oxygen is 3. Now this is a common problem we see in combustion reactions. Whatever coefficient I put right here, I will always have an even number of oxygens. Because if I put a 2 here, I get 4. If I put a 3 here, I get 6, because we're always multiplying the coefficient by the subscript to get this number. This will always be an even number because we have O2. Now over here we have an odd number, so we need to do something over here in order to make this an even number. But for right now, we're going to put this on the back burner. When we learn how to balance reactions, there is one rule I talk about, and that is if you have an element in multiple things on one side, to save that one for last. This will help you have some ease in balancing, so we are going to save our oxygen problem until a little bit later. Let's start looking at our carbons. Here we need 3 carbons to match what we have over here. What I'm going to do is I'm going to simply put 3 right here. Now this will give me 3 carbons now. So we cross that out, we don't have 1 carbon anymore. And it also changes our oxygen count. We have 6 oxygens right here, but we also still have this 1 sitting right here. That will give us a total of 7. Now, we need to deal with our hydrogens. Right now, we have 2 hydrogens on the product side, but 6 on the reactant side. What we're going to do is I'm going to put a 3 in front of here. And what this is going to do is going to give us our 6. Now let's recount our oxygens. In this case, we have 6 oxygens right here and 3 oxygens right here. That gives us 9. Now we've run into a problem. Our problem is that the number that I would have to put right here to balance this is 4.5. We have to have a whole number, so 4.5 or 4.5 wouldn't work right here. This is a common problem with combustion reactions, and there is a very simple solution when we do this. We need to go through and double all of our coefficients except the one right here. So what we're going to do is I'm going to not touch our O2, but I'm going to double everything else, and I'm going to use a purple pen to show this. So this one, if there's no coefficient, it's an implied 1. I'm going to make that now a 2. That's going to change some of our values. We now have 6, and we now have 12. We're not touching that O2 yet because that is our concern. We're doubling everything else. I'm going to double this one. Doubling 3 makes 6, and doubling 3 makes 6 as well. Now I'm going to redo my counts. I have 6 carbons, I also have, let's count our oxygens. I have 12 from right here, and I have 6 more from right here. 12 plus 6, that's going to give us 18. You might be noticing our previous counts are just doubled because we're doubling our coefficients. And then right here, instead of 6, we have 12. Well, now we have a way for us to balance our oxygens over here. We don't have to put 4.5 because now instead of 9, we're trying to get to 18. Well, we need to think what times 2 equals 18, and that's a number that is a whole number. It's 9. Now we have our 18 oxygens. In this case, we are all balanced. We have 6 carbons, we have 12 hydrogens, and we have 18 oxygens. If you ever come into a case where you end up not being able to get a whole number here, you can go and double all of the other coefficients. Don't touch this one yet. Double all of the other coefficients, and then you will have an option to do this. So right now, our coefficients, I'll write this a bit cleaner, are 2 C3H6 plus 9 oxygen gas goes to 6 CO2 plus 6 H2O.